Okay, so last time we were in the other part we were talking about the traditional method. In this part, we're gonna talk about the p-value method or probability value. So basically, this is comparing areas, right? The other traditional method just compare the C value, right, or the C test with the significance level. So here we're comparing this area. So the p-value or probability value is the probability of getting a sample statistic such as the mean or a more extreme sample statistic in the direction of the alternative hypothesis when the null hypothesis is true, right? So hypothesis testing, in this section, the traditional method, we compare the C values, right? The critical value with the test value, right? The p-value method for solving hypothesis testing compares areas, like I mentioned before, alpha and the p-value, right? So this is not a big deal. I will show you how to do it. So first you need to state same thing like before, right? State that the hypothesis and identify the claim, compute the test value, find the p-value, make the decision, summarize your results, right? Let's go straight to the point. So we have this problem. I already copied that in the other side, and let's go straight to this, okay? Let me do this thing here. So a researcher wishes to test the claim that the average cost of tuition in fees at four-year public college is greater than 5,700, right? So greater means that the alternative should be 5,700, right? And the null should be less than or equal than 5,700, right? So this is the claim. It's more than, and the null, it says it's equal or less than that. So she selects a random sample of 36 and 36 four-year public colleges and find out that the mean of the sample is 5,950, right? The population standard deviation is 659. Just remember, population standard deviation means the population of the parameter that we're trying to infer, right? Is there any evidence to support the claim at 0.05 using the p-value method? So the first thing I need to do is I need to understand that this is a C test because the sample size is 36, and they give me the population standard deviation, so I can use the C test. So this is X bar minus mu sigma, and so X bar is 5,950. The mean is 5,700. Sigma is 659, and this is 36. So we need to compute this. You get 250, I believe, here, and this is 659 divided by 6. What do you get? 1 point something, 109 point something. So that's going to be, the C value is 2.28. So that's what I have. So because we're doing the p-value method, I need to look, and remember, this is a right tail test, right? Because they're asking you for greater. They said the mean, it should be greater than the C value. So I need to look for that value, but usually I will have to look for, in the other method, we look for sigma, that is 0.05, right? And we look for the area. But in this method, I need to look for this area of 2.28 in my table. What probability value is corresponding to this 2.28? So if we look at the table, 2.28, it should be here somewhere. Let's see, 2.28. So 2.28 is here. I found it already. So this is 2.28. This is the probability, 0.9887. So the probability is 0.9887. But remember, I need to subtract that from 1 because this is what? This is a right tail test. Remember when we have 1 minus alpha when we were doing the right tail test? So the same thing I have to do. I have to subtract 1 minus the probability of 0.9887. So if you do that, 1 minus 0.9887, you get 0.0113. Yes? And once you do that, you need to compare it with the p-value that you have, right? So this is the p-value that you found. This is 0.0113. So basically, reject or not reject is based on this alpha and then this p-value. So the p-value that we found, right, is this guy right here. So if the p-value is less than alpha, we reject the null, right? Because this is less than the significance level, we reject the null. if the p-value is greater than alpha, we fail to reject, right? Okay. So in this case, we fail to reject because the p-value is less than alpha. Therefore, we reject the null, and we said reject the null. We said reject the null, and we said that there's not enough evidence to. We said that actually there's enough evidence. There's enough evidence. Therefore, there's enough evidence to support the claim, right? Support the claim that what is it, the average cost, that the average cost of tuition and fees at a 4-year college public, so is greater than $5,700, right? So I'm not gonna do all over, but you get the point. So this is what they're trying to tell you. Okay, that's it. That's all you have to do. So you reject the null if your p-value is less than alpha. If your p-value is greater than alpha, forget about it. Don't reject, right? So that's what's on your slide, right? Okay. Next, let's do another one. Do this for you. So let's do that here. So here they say a research claims that the average wind speed in a certain city is, look at this word. A researcher claims that the average wind in a certain speed is. So remember I told you, right? You need to remember the null is always is, right? So the mean here is 8 miles, right? So the alternative, this is the claim, right? The alternative is a sample of 32. This has an average wind speed. This is the X bar is 8.2 miles, right? And the standard deviation of the population, okay, that's sigma, 0.6 miles. At 0.5, is there enough evidence to reject the claim? So not equal 8 miles. So this is a two-tailed test, right? Okay, so let's do it. C equals X minus mu sigma n. This is 8.2, the mean is 8, the standard deviation of the population is 0.6, n is 32, and you subtract these two, so this is 0.2, and whatever that is, right? 0.6 divided by 32, and then 0.2. You should get, for this result, you should get 1.89. So that's your C value. But remember, we're looking for the P value, right? So once we find that, we need to find this probability, right? In the table. This is the C value, and we need to find the probability. So if we find the probability of 1.89, right? So 1.89, so that's right here, 1.89. The probability is 0.9706, 0.9706, right? And if I want to find out this is a two-tailed test, right? So if I want to find out this value, right, here, or the p-value, I need to do 1 minus that, right? If it's for that location. So 1 minus that, 1 minus 0.9706, you get 0.0294. However, because this is a two-tailed test, you need to multiply that by 2. Okay, or you need to multiply by the absolute value of that. So if you multiply that by 2, you get 0.0588. Okay, so this is your p-value. So your p-value is, in this case, more than your significance level, right? So the p-value is more than the significance level. Therefore, before we said when the p-value is less than alpha, we reject the null, right? We reject the null when the p-value is less than alpha. When the p-value is greater than alpha, we fail to reject, right? Because this time the alpha is greater, so we cannot reject the null. So we fail to reject. So this is our conclusion. So now we need to summarize our final statement, right? So we should say, therefore, there's not enough evidence to support the claim, right? There's not enough evidence to support the claim. And you understand what I have to say next, right? I mean, there's not enough evidence to support the claim that the average wind speed in a certain city is different than 8 miles per hour, right? Okay, so you can continue this. Okay, to save time. Okay. Okay, so here they have some guidelines for the p-value with no alpha. If the p-value is 0.01, reject the null hypothesis. The difference is highly significant. Make sure that you know these things. If the p-value, I might put this on the test. If the p-value is greater than 0.01, but p-value is less than 0.05, then we reject the null hypothesis, and the difference is significant, right? When the smaller the p-value, the more significant it is, right? Basically. So if the p-value is greater than 0.05, but p-value is less than 0.010, then we consider the consequences of we might have a type 1 error, right? Reject when it's true, this kind of situation, right? And if the p-value is greater than 0.10, do not reject the null hypothesis. The difference is due to chance, so it's not significant, right? So make sure that you remember this. Make sure that you know this thing. Okay. Okay. Good. So significance. The researcher should distinguish between statistically significance and practical significance. When the null hypothesis is rejected at a specific significance level, it can be concluded that the difference is probably not due to chance, and thus is statistically significant. However, the results may not have any practical significance. It is up to the researcher to use common sense when interpreting the results of a statistical test. So what this means, statistical significance and practical significance. For example, right, something can be statistically significant, but in practice, it might not be meaningful, basically, right? So for example, like, the politicians, they always claim about this, if they want to have a free tuition for university students, right? So we have all this debate between should we let the students go to school, and the claim is that that will increase their salary in the long run. But if the salary increase, let's say, is 100 hours or a year, then it might be statistically significant that, I mean, it might increase their salary, but it's like statistically significant doesn't tell you by how much, right? It just tells you it's significant. That means it's not due to chance, but it doesn't tell you the meaning of this, right? So if the salary of, like, I don't know, a professional or a 4-year student or 4-year professional, it increased by 100 hours a year, then it's not worth the investment. So it means it might be statistically significant, but it's not meaningful in practice. So like investing money in, let's say, in a college tuition for students, it might not be worth it if just the salary or the increase in salary, it will be only 100 hours. However, if, for example, if we're going from 50,000 to, I don't know, 150,000 per year, if there's an increase, this might be statistically significant, of course, and it might also be significant. It's the practical significant, right? Because it's also meaningful. So there's if we're investing in paying the students, right, or the government is investing in the students, not to pay the tuition, right? Then if the salary increase is $100,000 a year, then that's meaningful, right? So one of the requirements for meaningful significance or practical significance is that it has to be statistically significant. But because something is statistically significant, that doesn't mean in practice it might have no meaning, or it might be not meaningful. So just keep this in mind, okay? So that's what this means, okay? Okay, t-test. The t-test is a statistical test for the mean of a population, and is used when the population is normally or approximately normal distributed when sigma is unknown. Now you don't know this thing, okay? So the formula for the t-test is this, right? And remember the t-test, we have to consider, or we have to keep into account the degrees of freedom, right? Which is n-1. When the degrees of freedom are above 30, some textbooks will tell you to use the nearest table value. However, in this textbook, you will use the table that I will give you on the test notes, so don't worry about this thing. Okay. So here they want you to find the critical value for a 0.05 with degrees of freedom of 16. So, so they give you the degrees of freedom already, and it's a right tail test, t-test, right? So you need to look for alpha 0.05 and degrees of freedom of 16. Okay, so 0.05 is a right tail test, they said, right? 0.05 and 12 degrees of freedom, I believe they said. So this is the result, right? If it's a one tail test and 12 degrees of freedom, it would be 1.78, right? So it was 16 degrees of freedom, I'm sorry. 60 degrees of freedom, so that should be here. So the answer should be still is 0.05, and it's a one tail test. Notice how I color the one tail. You see, this is one tail. It means 0.05, right? And 60 degrees of freedom. This is result, right? This thing right here, 1.746. So you should get this, right? Okay. So find the critical t-value for a 0.01 and 22 degrees of freedom for left tail test. Again, it's one tail test. So 22 degrees of freedom, 0.01. 2 degrees of freedom, 22 degrees of freedom, 0.01, right? 0.01 is one tail test, 0.01, one tail test. So result should be this guy right here, 2.508, right? So the result should be, let me see if I missed something. Okay, here it is. Result, because this is a left tail test, you have to put a negative. Don't forget that, right? Because this is also symmetrical. So when I found the table, I found 2.508, but because this is a left tail test, right? Don't forget, this is the t-test, the student test, right? It's also at the left tail. So if they're asking you for left tail test, make sure that you put the negative, okay? But anyway, it's 2.58, right? Okay, so that's it. Okay, find the critical value for 0.10, 18 degrees of freedom for a two-tail t-test. So 0.10, 18 degrees of freedom, 0.10, 0.10, 0.10, it's a two-tail test, 0.10, 0.10, that's a two-tail, because they said two-tail, and they said 22 degrees of freedom, and that's here, right here, right? So 1.71. So 1.71 or 1.72, right? So it should be negative 1.71 or negative 1.72, right? So this is the answer. This 18 degrees of freedom. How many degrees of freedom I put? I put 22. It's 18, right? 18 and 0.10. So you can see clearly that is 1.734. Sorry about that. 1.734. 1.73. Anyway, that's result, right? That's very easy. You guys can do that. Okay. So here they give you example and we have to solve the problem, right? Okay. So let's do that. Okay. So let's do that here. Okay, a medical investigation claims that the average number of infections per week at a hospital in Southwest is so the average is 16.3. A random sample of 10, so you know that that's a t-test right away. A random sample of 10 weeks had a mean of 17.7 infections. The sample standard deviation, so that's S, is 1.8. Is there enough evidence to reject the investigator's claim? Okay. So first I need to state my hypothesis testing, right? I need to state the claim and the null hypothesis, right? Claims that the average number of infection per week at a hospital is. So they're saying that is, right? So is always null. So this is supposed to be here, right? So this is the claim. The mean equals to 16.3 because is, right? They're saying that that's is. And the null hypothesis should be not equal, right? Not equal to 16.3. Let's read one more time. A medical investigation claims that the average number of infections per week at a hospital in South is. So this is the claim. Remember, the null is always is, right? Or equal, right? In this case, a random sample. Okay. So now we can solve the problem, right? So this is t-test. This is x minus the mean over the sample standard deviation and sample size. So x equals 17.7 minus the mean is 16.3. The sample standard deviation is 1.8, n is 10. So let's compute this, right? 17.7 minus 16.3, 1.4 divided by 1.8 divided by square root of 10. You get 0.5692. 1.4 divided by that number is 2.46. Okay, so that's my t-test. Now I need to compare that with the significance level, right? So the significance level is 0.05. And I have the degrees of freedom should be n-1. So in this case, it's 10-1, so that's 9. So this is the value that I need, and this is the other value that I need. So I need to look at the table, 9 and 0.05. And this is a two-tailed test. 9, 9, and 0.05. 9 and 0.05, and this is a two-tailed test. 0.05. 9 and 0.05 two-tailed test. So this is a two-tailed test. This is 0.05. And 9 degrees of freedom, this is supposed to be 2.26, right? 2.26. So remember, this is a two-tailed test. 2.26. So this is negative 2.26. This is 2.26. And the value that I got is 2.46. So that means that's in this region. So that's the rejection region. So we reject the null, right? We reject the null, and we say reject the null. And we said this is our conclusion, and our statement or our conclusion should be there's enough evidence to support to reject. There's no evidence to reject the claim. The claim that the average number of infections per week at a hospital in southwestern Pennsylvania is 16.3. So we reject the the null hypothesis in this case, right? Because our t-test is in the rejection region, right? It should be here, and then we can reject that. Okay, so let's see. 0.46. So notice that, where is that thing? The claim was in the null, you see? So the name, the claim can be in the null too, right? So we said there's enough evidence to reject the claim that the average number of infections is 16.3, right? Okay, let's do another one. Erase this thing. Okay. Copy that. So here, an educator claims that the average salary of substitute teacher in this district, Pennsylvania, is less than. Okay, so that's the claim. You know what it is. It's less than. So it's less than $60 should be here, and the null should be greater or equal than $60, right? So a random sample of 8 school districts is selected. Okay, so sample size is 8. And the daily salaries in dollars are shown below. Is there enough evidence to support the educator's claim at 0.10? The first thing I need to put this in the data, right? So let me share this with you. Let me put this in the data. 1 second. Let me show you how to do that if you forgot. What is that thing? Here. Okay. So let's input our data. So we have, I go to stats here. I need to put 60, 56, 60, 55, 70, 55, 60, 55. Okay. So 60, 56, let me double check my input. 60, 56, 60, 55, 70, 55, 60, 55, stats, calculation, and we do this, and we get our values, right? So our mean is 58 point, let's see what numbers they use. I'm gonna use 8, I'm gonna use 2 values, 80, 88, 2 decimal places, to the 10 to the 100 places. And the sample standard deviation here is 5. Let's see, what 5.08. I'm gonna use 5.1. Okay, and let's see. That's it, right? Okay, now we're done with this. Let's go back to the slide. Okay, let me go back to the slide. In 1 second, let me get from here. And now let's go back to this one. I'll share this with you. Okay, so now we have everything that we need. So we need to solve this problem. So the t-test equals x minus mu sigma of the sample standard deviation over the sample size. So this is 58 point, let's round it to 9, minus the mean is what, 60, and then sample standard deviation is 5.1, square root of 8, whatever that is, right? So this is 58.9 minus 60, and then this 5.1 divided by square root of 8, and we get 1.80. So negative 1.1 divided by this number, you get negative 0.61. Okay, so this is a one-tailed test, right? So remember that. So this is a one-tailed test, and it's a left-tailed test, right? And I need to find this value, right? So alpha is 0.10, and the degrees of freedom should be a minus 1 or n minus 1, which is 7. I need to look at the table. This is only one-tailed test. It's a left-tailed test. So 0.10 and 7. So 0.10 and 7. 0.10 is a one-tailed test, and 7 we said 7 is here. Until test is 7. Is 1.42, right? So 1.42, but it has to be negative because it's less. Now what we need to do is state if we reject or not. So our value is negative 0.061. That's not to the left. That should be somewhere in the non-rejection region, right? Somewhere around here. Therefore, we fail to reject, right? So we can fail to reject, right? That's our conclusion, and our final statement should say there's not enough evidence. There's not enough evidence to support the claim, right? This is the claim, right? This is the claim. There's not enough evidence to support the claim. And you know what is next, right? The claim that the average salary of a substitute teacher in the school district of this county is less than 60 hours per day, right? So this is where you need to state, right? Okay, that's how you do that. Okay, let's continue. Okay, there's more here, more t-test. Okay, let's do this one. Okay, so here they say a jogger's oxygen intake. A physician claims that the jogger's maximal volume oxygen uptake is greater than the average of all adults, right? So that's the claim. He claims that the average, the maximal volume oxygen uptake is greater than the average of all adults, right? So it's greater, yeah. So a sample of 15 joggers has a mean of 40.6 milliliters, right, per kilogram. And what else? And the standard deviation of the sample should be 6 milliliters per kilogram, right? If the average of adults is 36.7, so that's what they're saying, right? Greater than the average. So this is supposed to be 36.7. This is the claim because he said that it's greater, and the null should be that it's less or equal than 36.7, right? Okay, is there enough evidence to support the physician's claim at 0.05? Okay, so we do the same thing, again, same thing. We do the t-test, right? So this is x minus mu, sigma, not sigma, the sample standard deviation, and square root of n. So this is 40.6 minus the mean, which is 36.7. S is 6 and square root of n is 15. So subtract that. And then 6 divided by root 15. This divided by this, you get 2.5, 2. And that's the t-test, and we need to check with the significance level, right? So 0.05. Yeah, so we need to check, right? So 0.05, and then degrees of freedom is 14, right? N minus 1, so that's 14. Okay, let's check on that. And then this is a right tail test, right? Because we're looking for the, if it's greater, right? Okay, so let's look for that t-value, 14 and 0.05 right tail test. 14 and 0.05, 14 and 0.05 one tail test. Actually, it's right tail test, right? So it's 1.76. So 1.76, 1.76, that's the right tail test. And my t-value is 2.52, so that's in the rejection region, right? So therefore I can say reject the null, reject the null. That's my conclusion. Therefore, you say there's enough evidence. There's enough evidence to support the claim that the maximum volume oxygen uptake of yogurts is greater than the average of all adults, right? So you can say that. That's it. That's all you gotta do, okay? And that's the end of this thing. Okay, good. Let's continue. They use the p-value method. I use the traditional method, so it's fine. Anyway, should be the same result, right? So what is their conclusion here? Okay, it's the same result as you can see, right? If you use the p-value method or you're using the traditional method, right? Okay, so the question becomes when I use the c-test and when I use the d-test, you have to ask yourself this question: is sigma is known? If yes, you use the c-test, right? And if n is less than 30, as they claim here, the variable, or in the problem, they must say that the variable is normally distributed. If sigma is not known, and you're using the, for example, this sample standard deviation, you have to use the t-test, right? And you have to use the sample standard deviation, right? That's it, right? Ask yourself this question when you're doing the problems, okay? I'm gonna stop here, and the other part I will finish the slide, okay? I'm gonna stop here to don't make the video too long.